So can you confirm recording is on or not? Recording.
Yes, sir. It is not recording.
You're okay. Okay, so today we will start a new topic, that is constructors and destructors. Okay, so in C++ programming, one of the aim is to create a user-defined data type, such as a class that behave very similar to the built-in types. What does it mean that in normal C program or in C++, for the built-in data types, we can define a variables like this. But in C++, okay, so what does it mean? It means that we should be able to initialize a variable whenever we can declare them. Similarly, for the object types, we should also be able to initialize that object when it is declared, much as the same way as we initialize our built-in data types. So in C++, so far what we have seen is that what we do, we create some member functions such as, say, input function or set value. These are the methods with which we can pass parameters like this, which can be used to initialize our objects. That means, suppose if you have a class, say class A, which have a data member int A, so we will use this kind of member functions in our public part, which are called from the main function, and then we send data. So in this case, what happens is that object doesn't behave very similar to the built-in types. But can you please confirm whether I'm audible or not?
Yes, sir, you are audible.
Okay, thank you. So in this case, our user-defined objects, that means class data types, doesn't behave similar to the built-in types. We require a member function so that we can set values. That means we are facing problem of initialization. For this, C++ provides a special member function which is called as constructors, which enables an object to initialize itself when it is created. Is this clear? Like in built-in data type, we can declare a variable, and at the time of creation, we can also provide the initial value. But in object-oriented programming, where we use an object of some class type, we require member functions to set values. To make this thing similar to the built-in data types, we use constructors. Those are special types of member functions. Let's take another example, another problem. That means if you use a constructor, then you can also provide some domain constraints. What are domain constraints? Suppose we have a class named date, and if you create an object of date class, that is d1, now suppose this date class may have data members like day, month, etc. But using these member functions, if you set values, you can set a value like this, d1.month equals to 13, You know that the value 13 is incorrect, but you cannot restrict a user to provide this value. So in this case, the domain constraint for the month, that means month should vary from 1 to 12, but here we are assigning a value 13 which is incorrect, and we cannot avoid that. Similarly, suppose if you have a distance class, suppose in this class we have data members like inches and say feet. So in this case, you know that the value of inches should be from 0 to 12, but using data members like set inches, you can pass a value like 22. We cannot avoid that. Is this clear? Hello?
Yes, sir.
So are you getting my point?
Yes, sir.
Yes, sir.
Okay. So in this case, what happens is that these conditions may get violated in case an object has just got created. Means whenever you create an object, that object will contain garbage value. So during the time of object creation, they contains garbage value that may they may violate the domain constraint. And again, if you provide incorrect data, then again you cannot restrict them. So in both the cases, we have a member functions, a special member function which is known as constructor, which is used to initialize an object, and we can also apply our domain constraints. So what is a constructor? So constructors appears as member functions of each class. Whether you define a constructor or not. Like normal member functions, you require to declare them and to define them. But whether you define or not, each class contains a member function which is known as constructor. Another property of constructor is that it has the same name as that of the class. For example, if you have a class called date, then you must also have this member function date function, which is a constructor. Similarly, if you have a class distance, then this class will also have a constructor like this. So this is a constructor for distance class. This one is the constructor for date class. The name of the class and the constructors must be same. Now what happens is that whenever an object is created, the compiler embeds a call to the constructor. That means if you create an object of class distance like distance d1, then compiler will embed the function call, the constructor call to this function, which will ultimately initialize the value of d1. Like these normal member functions, whenever you create an object of distance class like this d1, so you must have to call this member function like this. But in case of a constructor, compiler will embed this constructor call whenever the object d1 gets created. Next property is that the constructor gets called automatically for each object that has just got created. Now constructors may or may not take parameters. Like here, this member function set value doesn't have any argument, but you can also pass arguments. Similarly, the constructors may or may not have parameters. What should be the return type of constructor? Constructor doesn't have any return type. So constructor doesn't return anything. That means it doesn't return even void. Is this clear? If you have any query, you can ask me. So the prototype for the constructor is class name, within bracket, parameter list. Is it clear now? Now let's take one example. Suppose we have a class A like this. It has a data member, say int x. We have two member functions like void set x to set values. Then we have get x, so that we'll take values from this object. Now here we created an object of class A1. So here we have created an object. So in this case, compiler will embed a call to the constructor. So after the creation of object A1, constructor will get called. So you already might have know that after the compiler ascertained that no attempt has been made to access the private members of an object by non-member functions, it converts the C++ code into an ordinary C language code. I think you know this. The classes are converted into constructors, and the member functions are converted as a normal member functions. Do you know them? The this pointer?
Yes, sir.
Okay. So here, whenever you create an object like this, means whenever you write this statement as A1, the compiler performs some things. The compiler converts this following statement A1 to A1 dot A. Is this clear? This is converted implicitly by the compiler. So here you can see that the object A1 is there and we are calling a function A. That means the class A should have a member function like this. After this statement is converted to this, compiler again converts this into A ampersand A1. That means A is a member function, is a function where address of A1 is passed. And it will be taken to this pointer. Similarly, suppose, okay, so if you are creating an object dynamically in the heap by the new operator, then what happens? Class name is A, pointer, aptr equals to new A. So this is the statement to create an object dynamically. Here again, the compiler will convert this code to aptr arrow A. Again, it is converted into A APTR. Is this clear? The constructors are called in this manner separately for each object that is created. That means you have written this single statement. Compiler at first converts it into this and then to this one. So with these examples, we should be very clear that unlike the name constructor, the constructor doesn't construct any object. Means objects are declared and defined. That means objects get created, and when objects is already created, a call to constructor is done. So before the call to constructor, the object is already created, so it doesn't construct any object. And again, constructor do not actually allocate memory for objects. You require different statements so that you can allocate memory, but constructor itself doesn't allocate any memory. But they are member functions that are called for each object immediately after memory has been allocated for the object. Is this clear now? If you have any doubt, you can ask me. Okay, so in the previous example, where we have declared a class, where we have data members, and we created an object of the class A1. So you know that here we didn't prototype and define a public function with the name A function inside the class A. We haven't defined any function like this. Then how did this function get resolved? Means when you declared, you have created this A1, then compiler converted it into this and then this. That means there is a function call to a function named A and some argument is being passed. But we haven't defined any function like this within class definition. Then how this constructor call get resolved? The answer is that the compiler prototypes and defines the constructor for us. This constructor, which is provided by the compiler, is known as default constructor. So what statement does this definition of default constructor will have? The answer is nothing. It doesn't have anything. So suppose we have a class named A and we haven't defined any constructor here. Then after the compilation, compiler will provide definition and prototype the default constructor like this, and it defines the constructor as this one. So it doesn't contain anybody. However, this is compiler dependent. Is this clear? These statements for the prototype and the definition is provided by the compiler so that the call get resolved. So with these examples, you can see that the name of the constructor is same as that of the class name. The constructor doesn't return anything, not even void. The compiler defines the constructor in order to resolve the call to the constructor that it compulsorily places for the object being created. So this is the example of default constructor. So the term default constructor refers to a constructor that is automatically generated by the compiler in the absence of any user-defined constructors. So this constructor is provided by the compiler, but obviously you can also define your own constructors. But if you provide your own constructor, then default constructors will not be available. Compiler will not provide any default constructor name. Any questions? The concept of default constructor is clear to all of you or not?
Yes, sir. It's clear, sir.
Yes, sir.
Okay, thank you. So default constructor is the one type of different types of constructors. The next type of the constructor which we will discuss is zero argument constructor. So we can and should define our own constructors if the need arises. If we do so, the compiler does not define the constructor. However, it still embeds implicit calls to the constructor as before. So for the class A, let us add our own constructor and verify whether the constructor is actually called implicitly by the compiler or not. So let's take the example. Here, if you declare a class like this, here we have int x in public. We prototype our own constructor like this. Next, we can have our other member functions like setx, and we can have getX method. Now, the definition for the constructor, the class name, it doesn't return anything. So class name is scope resolution operator, name of the constructor. In function body, let us print this message. Constructor is called. In main, we can have A1 as object, and let's print a message end of program. Okay, so in this case, when this statement A1 is found, the compiler will convert this to embed a constructor call. It will call a method like this. So this constructor method will get called. The message will be printed like constructor is called, and then this message will get printed. So the output will be constructor is called and in the program. Is this clear? Today I am not writing this code in the compiler, otherwise I could show you the output. Now let's take another example of distance class. So here we are defining our own constructor for this class. What happens is that this class will contain two data members, ifit and say f inches, where inches is of type float and feet is of type integer. So what we like is to set the values of the ifit and f inches, these data members, when the objects are created. So our constructor will set the value of ifit to 0 and f inches to 0.0 when the object gets first created. So let us add the prototype of the function within the class definition. So what we do in public section, we will write the prototype for our constructor. Now rest of the code within this class. The definition of the distance constructor is no return type, class name, scope resolution operator, name of the constructor. It doesn't take any argument. I feet equals to 0 and f inches equals to 0.0. So in main function, if you create an object of class distance like this, then if you call a member function such as getFit, it will return the value of this data member as 0. So getFit is a member function which should be defined within the class definition. So this program is clear to all of you or not? Here what happens is that here we have created our own constructor. So this is not a default constructor, but the user defined constructor. Since we have provided our constructor, compiler will not provide any default constructor. So due to the constructor, what happens is that there is a guaranteed initialization of the data of all objects of the class distance. Our objective to keep the value of f inches within the 0 to 12 can also be fulfilled, because whenever the object is created, it will not contain any garbage value, but it will contain 0 for feet and 0.0 for f inches. So here the constructor that we have defined doesn't take any arguments and is called the zero argument constructor. That's why the name. Here it doesn't take any argument. The constructor provided by default by the compiler, that is default constructor, also doesn't take any argument. Therefore, the terms zero argument constructor and default constructors are used interchangeably. In many books, you will find that there is only one declaration for the constructor, that is default constructor. So default constructor is provided by the compiler, and the zero argument constructor is a user defined constructor which doesn't take any arguments. Okay, now let us take another example. So here we will consider a class that will enable us to abstract character arrays and overcome many of the drawbacks that exist in them. So here we will take two running examples. One is for class distance and another is the class which I will write now. We will incrementally add some of the portions, some of the codes, so that we will get a full-fledged class. So here, this class is called as string. In C++, we do not have much support for string class. So we use normal character arrays. With this class, we will take character arrays and we will provide some facilities so that some part and some tasks of strings can be performed on this. So this string class will have two data members. See character pointer CSTR and long unsigned int length. Both the data members will be private. The first data member, that is character, this one is a character pointer. It will point at a dynamically allocated block of memory that contains the actual character array. The other data member, that is long unsigned integer, it will contain the length of this character array. The rest of the code, which we will write later on whenever the need arises. Now, suppose we have an object of this string class as S1. So this S1 will have two data members, the length and CSTR. The address of this object is suppose 27. If you assign a string say ABC to this object S1, what happens is that you need to provide the value of ABC string. So it will be stored somewhere in the memory like this. Suppose the address of this memory is 101. So when you create the object S1, what happens is that you need to store, means you need to point to this string ABC. So what should be the value of CSTR? It should contain the address of the first block. The length of the string will be 3. So this is our objective. Now with our um, with our constructors, what we want to do, we would implement two conditions on all objects of the class string. What are our objective is, the first one is that the CSTR should either point at a dynamically allocated block of memory which is exclusively allocated for it. Otherwise, CSTR should be null. If CSTR is not pointing to anywhere, it should be null. Otherwise, it will point to some garbage value. And if it is pointing to somewhere, it should point to that location. It should point at that location only. The next objective is there should be no memory leak. Can you tell me what is memory leak? Do you know what is memory leak? Am I audible? Hello.
Yes, sir. Yes, sir.
Yes,
You
sir.
are audible.
Yes, sir.
Okay, so please tell me what is memory leak. Okay, so here suppose we have the object S1. CSTR is pointing to some address, length is 3. The address is this 101 is the starting address of another memory block which contains the string ABC. Now suppose, like in any normal function, normal program, C program, if your variable, like
I
suppose,
think, if we don't stop a dynamic array, I mean, and then the memory keeps on getting used, and finally the program crashes.
no, it's not like that. Uh, Suppose you have a variable like int a. Suppose you have declared it somewhere in a function like fun. So you know that int a will get defined whenever this function will get called, and when this function terminates, At that time, the memory occupied for A is also get recovered. But suppose in this example where we are using a character, where our class is string, here we are using a character pointer CSTR. The objective is that our string object S1 will contain the length and the starting address of this character string, character location. So this is the address of our memory. Starting address is 101, which is stored here. Now suppose when this S1 goes out of scope, that means suppose you have declared this object string S1 within this function. So memory gets allocated for S1. S1 is pointing to some dynamically allocated block. Now when this function returns, S1 also gets removed. When this S1 goes out of scope, what does it mean? That memory allocated for S1 is retrieved. I suppose the address of S1 is 27. Now the operating system can use the address block starting from 27. But you can notice that this dynamically allocated block of memory, which is starting from 101, it is not recovered. In C, you have to use calloc, calloc and malloc to allocate memory, and you use free to recover that allocated memory. In C++, you use new operator to dynamically allocate memory, and you use delete to remove the dynamically allocated memory. In this case, since you haven't removed this dynamically allocated memory block, it is still in use. So operating system cannot use this memory block. However, you know that since S1 is already destroyed after it is going outside the scope, the use of this is not possible because you do not have any pointer which will point to this address. That's why it is known as memory leak. Is this clear now? Hello.
Yes, sir.
Okay, so okay, so let's write the zero argument constructor for string class. For the initial object is that whenever any object of class string is created, the data members character pointer CSTR should point to null and the length should be 0. So what should be the constructor? Here the name is string. It has two data members. CSTR is the character pointer. So in public section, we will write a constructor. The name of the constructor is same as the class name. This is the prototype. Rest of this class. Here is the definition. Class name is scope resolution operator. Constructor. Okay. So this is the user defined constructor, zero argument constructor for the string class, which initialize any object of a string class where CSTR will point to null and the length is 0. Okay, now with these examples, you have seen that whenever we declare a constructor, it is declared within public part. So can you tell me if instead of public section, if you define your constructor also in the private section, then what will happen? Can you declare a constructor in private or protected specifier?
No, sir.
No. So you cannot declare a constructor in private or protected. You must, you should declare this in public section. My next question is, if you define your constructor in private section, then what will happen? Will there be a compiler error?
No, sir.
No. Means can okay. Okay, let me clarify this thing. The user-defined constructor can also be declared anywhere, means like you can declare it under private specifier or in protected specifier also. But our objective is that you are creating an object of any class like distance class or string class or any other class. You create this object in public section like int main. That means you are creating this object outside of the class definition. Now, in this case, a constructor will be called like distance. This. Now, if you do not declare your constructor in public section, then this call will not get resolved. That's why we need to declare our constructor in the public specifier. But if you are declaring it in a private part, private area, private specifier, what will happen is that there are many situations. In that case, you need to define many classes. Like you can see in case of inheritance. In inheritance, you can have base class, and you will derive multiple uh, classes from that base class. Now, in many cases, base class are not complete. Okay, let's take one example. Let's consider a vehicle class. A vehicle class can have many data members. It can also have many member functions. But the task of vehicle class is always to create another derived task. Like a vehicle can be a car, it can be an aeroplane, it can be a bus. So car, bus, aeroplanes, these are derived classes. They may have full featured data members and the member functions. But vehicle class may not contain all the data members or functions which will be required in car as well as in trucks or buses. They may have different properties. So if in a program you have a vehicle class and a car class, so our objective is to only allow creation of car classes, car objects, but not the vehicle objects. So how can you restrict creation of any object for the vehicle class? The answer is you can declare the constructor vehicle class in the private. So compiler will gives you error whenever a call to this constructor which is defined in private specifier is called. Is this clear? So if you have any question, you can ask me. So I'll stop at this point only. I will send the lecture notes, lecture slides after some time. So at this point, I am stopping. Have a nice day.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.